the Arctic is an incredibly important system in the global climate system. So just like the Amazon are the lungs of the world, the Arctic is like our circulation system and feeds in to global climate change everywhere. Science also tells us that the Arctic is in crisis. We know, based on observational data, that we have lost 50% of Arctic ice in about 50 years. So just when the World Economic Forum was starting, the Arctic was very white, and over that time period, it is increasingly blue. Now, why would we care? Well, we care because of the albedo effect. And that is a thing in climate science where if something is white, it bounces off sunlight back out into the atmosphere and it doesn't absorb. As the Arctic Ocean and the glaciers have melted, we see that dark blue is absorbing more and more heat, which is feeding through the rest of the system. We also know that the Arctic ice is fracturing. It's getting thinner. I said we've lost 50% of it. But in terms of old ice, we've lost close to 95%, the vast majority of it. That is a huge concern for Arctic science. In terms of sea ice volume, the picture is even worse. Since the 1970s, we have lost 75% of the volume of Arctic summer sea ice. If you think of that as the insurance policy for the rest of the world to prevent catastrophic runaway climate change, we are in trouble. And we can see here the loss to today. Now, we've got Google Earth data that we're showing for the first time today, which is observational data of various places in the Arctic, which uses satellite data for 30 years and shows where we were in 1984 and where we are in 2009. This is in Alaska. This is another one in Alaska, and we can see that we are massively changing the topography of the Arctic. It is no longer white, it is increasingly green, and it is absorbing heat, and CO2 emissions, of course, are rising globally. So this is again in Alaska, in the USA, and as we approach 2019, the picture is stark. If we look at Greenland, which is a huge glacier, of course, in the Arctic glacier ice sheet, we can see again in 1984, it's very white. We can see as we progress through the 1990s and approach the 2000s and approach the current decade, we can see it's not so white anymore. And that's a physical change, that's observational data that is very stark and concerning. When we look at glacier melt, we can see that it is tremendous. The glacier sheet in Greenland has lost 4 trillion metric tons since 2002. In one day alone, in 2019, August 1st, we lost enough melt in the glacier to fill 4.4 million Olympic-sized swimming pools. Tremendous change happening in Greenland. We also see, though, that the Arctic is white, it's greening, and then we can see that the permafrost is thawing. Now, permafrost, of course, releases methane, which is a concentrated CO2 gas, and if all the permafrost in the Arctic is released, that is like adding in the CO2 emissions of all EU countries. It's a sobering thought. Again, how we can see here is that the Arctic is warming. The anomalies of the temperature are severe, and we can see how it's happening. So as CO2 emissions are rising around the world, we can see that that's coming back into the Arctic, and we can see how that is affecting us. Now, we're all affected by images of polar bears. We can see the polar bear looking for ice, looking for a place to rest. And indeed, as the Arctic changes, the situation is dire for many Arctic species and Arctic-based communities, of course. But Earth system science tells us that actually we are the polar bear too. Why is that? That's because the Arctic is feeding into the global climate system, is protecting through the albedo effect, and that is decreasing rapidly. We also see how the Arctic is building extreme weather events globally. So if the Arctic sea ice goes, data in research suggests that we will actually accelerate global warming by 25 to 40%. On top of that, if we take a look at extreme weather, we can see that the Arctic plays a key point. Now, certainly the Arctic had its own fires. We saw that in Siberia, we see that in various parts. But on top of that, because of the way the Arctic affects the jet stream, it affects crazy weather all throughout the mid-latitudes. So if you remember the Sonoma fires of last year, that is related to the Arctic change because of how it affects the jet stream. If we take a look at Australia, the Arctic does not have a direct correlation with those fires, but indirectly because we are driving global climate change because of the loss of the albedo effect. That will affect things like severe weather and fires everywhere. And it's not just fires, it's also the hurricanes, it's the polar vortex coming down through Europe and North America. On top of that, though, we can see that with the Greenland ice sheet, we are accelerating sea level rise. And this again is data looking at what are the projections. If we get to a 2-degree warmer world, we can see from some of the major cities around the world, including Tokyo and New York, that they will indeed be flooded. If we stay at the 1.5 Paris aspirational target, we will save the Arctic summer sea ice and prevent images like this happening when we get to 2 degrees. 2 degrees is not safe. 1.5 definitely is. So from a scientific perspective, from my perspective, that the Arctic is a barometer of global risk. What happens in the Arctic does not stay there. And what's at stake is not a geopolitical question alone or the short-term economic benefits from shipping or extraction. What's at stake in the Arctic is actually the future of humanity itself. Thank you.